Okay, so in this third and final video, we're going to talk about two more rules for analyzing run charts and then wrap up with some conclusions. In the first video of this, we talked about basics of run charts. We talked about how to create a run chart within Excel or a piece of spreadsheet software. In the second video, we talked about the shift and the trend as two of the statistical rules you can use for interpreting run charts. And now we're going to move on ahead to the next rule, which is runs. Runs are a little bit more difficult to sort of wrap your head around. They're not quite as obvious on face value like shift and trend are. So runs are defined as when the data on the graph crosses the median either too many or too few times. And what this may indicate is a non-random pattern and a non-random process. So the example that I've given you here is we're going back to admissions to medicine from the ER here. And so if we look at our data, you can see that, like with the others, you have a back and forth across this median here. You'll note that there's no shift, there's no trend. These stay the same across all 20 data observations that we have. But what tends to happen here is there are each data point is on the opposite side of the median from the prior data point, as opposed to the other charts where we saw, there were a couple that were above, and then they were crossed, and there were a few down here, and then it would go back up. And so this seems to be crossing the median too many times, right? So from this point to this point here, it crosses the median. From this point to this point, it crosses the median again. Okay. In total, it crosses the median 19 times. 1, 2, 3, 4, 5, 6, 7. So you can add all those up. What you need to do in order to determine if your runs are either too many or too few is you need to refer to a chart of rules that tells you how many runs you should have based on how many data points, how many observations you have in total. And so this goes back to that reference I gave you in the first video from Perla in BMJ Safety and Quality. And they've got a table that fulfills this need. So in that table, if you look for a chart with 20 points with none on the median, so none of these actually have a point on the median, and there are 20 data points in total. Anything more than 16 runs suggests a non-random pattern. And in this case, I told you there are 19 runs. There are 19 times when the data crosses the median. So that suggests that it's not random. So you need to be looking for other reasons, other explanations for what's going on with this data. So if you go back and you find out that these admissions to medicine are due to the admitting officer of the day program that we started, but that there are two doctors that are doing that program, and let's say that those two doctors alternate on every other day. And so one doctor tends to admit a few more people, and one doctor tends to admit a few less people. And so as a result, your process is non-random. And so that becomes important. Why? Well, how would you go about adjusting this sort of program? If you were to institute some sort of educational intervention, or if you were to try and establish some criteria for who needs to be admitted and who doesn't, it's useful to know what's causing the variation in your pattern to begin with, because then some interventions may be more or less effective. Okay. So the last rule we're going to talk about is not a rule, actually. It's more of a gestalt. And so this is the astronomical point. And the idea here is that when you look at your chart, if you see a point that is far, far away from all the rest of your data, if you have something that's with means, 3 standard deviations away from your data, that represents a special circumstance, a special situation. Some strange thing happened on that day, or that week, or that observation that stands out as an astronomical point, high or low. And so if we look at this chart, which represents, it's got data displayed for emergency department visits for acute alcohol intoxication. And we've got this median here that's 3.5, and we've got data that's bouncing around that median, and then boom, all of a sudden we have this astronomical point with 15. And then we move on for a little while, and then we've got another one up here of 18. So this suggests that you need to, again, go back to your process, go back to the people that are involved in this process, ask them what's going on. And so when you look at it closely, you're like, oh, wait a minute. These are occurring exactly 7 days apart. Oh, and these are both on Sundays. Oh, you know what's going on those 2 Sundays? Those are when we had football games. And so that then helps you to understand, well, maybe that was just too many people partying too hard, and that's how we ended up with these 2 astronomical points. All right, so let's wrap things up a little bit. Just a reminder that run charts are an excellent way to display and analyze data on continuous processes. Simple rules like this can be applied to analyze for significant changes in your processes. And run charts are really great because the time-linked data gives you a much richer understanding than simple pre-post testing. Hope you enjoyed the videos. Give me a follow on Twitter if you would, and have a good one.